Assalamualaikum and a very good day. Welcome to Biomedical Image Processing course, which is SMBE 4043. Okay, this course will be taught by me, Dr. Muhammad Ami bin Ash'ari, as well as Associate Professor Engineer Dr. Tan Tian Sui. Okay, I would like to give some briefing about my research background. Okay, my expertise originally is in image processing, and of course, image processing is a family of signal processing, which is why for those who learned image processing, actually they also know about the signal processing. So that's why if you go browse to my website, you will find out that I have done a lot of things related to signal processing, image processing, as well as computer vision. And then because all these things is also not so far to the what we call as nowadays a growing field, which is artificial intelligence. So which is why most of my project is also involve artificial intelligence, because later later in the first chapter we will try to define that. Okay, we will try to explain what is actually is computer vision, what is actually image processing, and how does this one relate to the signal processing, as well as the prominence technology, which is artificial intelligence. Because any artificial intelligence approach apply to the image or apply to the video, that is what we call as a computer vision. Okay, so if you want to know more about my research background, you may refer to my personal website. Okay. Okay, before I give some briefing about the image processing, let me explain about my research background. So you can refer to my website here. Okay, later you can read all the details things there. Just give some idea what is my research background is. Okay, so if you go here, that is my research interest, where I involved in developing the assistive technology, rehabilitation, as well as sport technology. And if you see here, I belong to two research identity, which is one is I am member of biomedical instrumentation and electronic research group, where it is based in School of Electrical Engineering, and I'm also a member associate fellow researcher of Sport Innovation and Technology Center, where I use my expertise, which is in signals, image, computer vision, as well as artificial intelligence, to develop a system for biomedical as well as sport technology. So which is why if you can browse to my current projects there, I have done a lot of things that related to that mentioned field. Okay, so let's go to my complete project there. So you can see that this is some of the complete project that I have done. Okay, including the final year project. Okay, you can see that I also developed the artificial intelligence for esport, where we develop we using the AI for predicting how to win the games, which is a very common game or very popular games nowadays for the youngster, which is PUBG. And then you also can see that previously I also developed some what we call as a coin recognition by using AI. Of course, coin recognition, the input is image, so that's why there's a image processing components there involved in this project. Okay, and then we also have done some project which is the input is in chest x-ray image, and then the system apply the AI to predict the type of pneumonia. Okay, try to predict the type of pneumonia based on chest x-ray image. Of course, this also involved with AI as well as image processing. And then we also have many things there. Okay, you can go and try to play this video and see the demonstration videos there to see how actually this system works. Okay, I'm also involved in signal processing, like this project where actually we obtain the signal, a motion signal, the signal is obtained from the motion signal, and from this motion signal or motion sensor, we try to extract some good features and feed into AI and try to recognize the daily activity that is performed by the patient or by the subject that wear that motion sensor. So this is in signal processing fields. Okay, and this is one of the implementation of image processing as well as AI in sport technology, where we try to track the player or the athlete that perform in this badminton match and try to track the movement. Okay, you can see this video, or you can see later, you can go to my website and see this is how actually the benefit of learning image processing, as well as if you, for those who take the AI, this is also one of the benefit, where if you learned artificial intelligence as well as image processing, then you can develop a system that related to image or related to video. Okay, this whole thing actually is called a computer vision. Okay, the computer vision is on the top of everything, and then inside the computer vision we have image processing as well as AI, where the integration between image processing and AI, then you can have what we call the whole system is called as a computer visions. Okay, so later if you interested to know more about my research interest, then you can browse to my website. Okay, so right now let's focus on the first. We will talk about our CIs there. Okay, oh, before that, make sure that you join this WhatsApp group, yeah, because later anything, any announcement, any discussion, we will announce in this WhatsApp group. So make sure that you join this WhatsApp group and ask your friend to, as well as to join this WhatsApp group, because later anything related to this course, then we will discuss here. Okay, now let's discuss our course information. Okay, this is SMBE 4043 Biomedical Image Processing. Okay, then I'm the coordinator of this course, and then we also have another lecturer, other lectures, which is Dr. Tan. And then this is the description of the course. Okay, you can read that one. Okay, this is as well is written in our e-learnings there. Okay, this course introduces the student with the introductory and intermediate level of image processing technique, and the area will cover the area of coverage would be the digitalization process. Say what is mean by what is the definition of digital image, and then from that digital image, how actually from the we try to give the students some exposure to what we call as an image enhancement and image restoration, where this algorithm itself will cover the image from affected, maybe your there's a faulty in your camera, for example, or faulty in your medical modality, image medical modality, that make the system produce a very bad image. So that is where the image processing take place, where actually you learn some algorithm or a few algorithm that can enhance the image by programming or by using a mathematical equation, where you can manipulate the pixels as well as the data inside the image. Then you can restore the image as well. You can remove the noise, for example, and it will help a lot, especially in as a biomedical engineer, you are helping the radiologist, because the radiologist need a good image where it can provide information that can make the radiology can interpret very well, okay, in diagnose some patient. So that is where actually you take there is actually where you take place, or you try to help them, whereby using the knowledge in image processing, actually you are helping a lot for this particular problem, or for this kind of problem in biomedical field. Okay, and regardless of image modality, doesn't matter, is it MRI, is it ultrasound, is it a CT scan, then for those who become the image processing engineer, actually their purpose is to enhance the image, to help the radiologist to overcome, to produce a good image from the bad image. That is roughly speaking about image processing. Okay, so let's go back to our course informations there. Okay, there are 4 course learning outcome there. By the end of this course, student be able to, number 1, describe the overall process involved in image processing. Okay, later we learn what are the overall process in image processing, and course outline number 1 is related to briefing, or you will know some surface knowledge about the overall process in image processing. And course outline number 2, where you have the knowledge in applying the image processing, several well or existing or what I said as a general image processing technique in solving problem in biomedical image. And the third one is to develop, okay, by the end of this course, the student be able to develop a common image processing technique in solving image processing problem. Means that when you have some problem, given a problem, then you know what are the technique involved, what are the approach is suitable to be implemented in this kind of cases, in order for you to enhance the image or to restore the image from noise, or maybe from faulty in your hardware, and so on. And then the last one, by the end of this course, the student will be able to present the image processing problem and solve using the MATLAB. Okay, because this one is later we will have some mini project that is conducted by Dr. Tan. So you need, given some problem, then you need to based on what you learned before, then you need to all this technique will be implemented by using the MATLAB. And then you want, actually this is a kind of experiment, given the problem in the we give some degraded image, then how to implement the MATLAB coding, where that MATLAB coding is represent the approach that you learned before, to solve or to improve the image in terms of removing the noise, or try to restore back the information, and try to remove all the noise which is make the interpretation of by the radiologist more difficult. So that is how we do that. Okay, and then okay, this is the topic that we'll cover later. Okay, there's the first topic, we'll talk about the basic of digital image. Of course, why we talk about the digital image, because nowadays it's very difficult to find the analog image, because analog image is actually the image that you see by your naked eyes. Okay, anything in the environment is an analog image. And another analog image you can see is if you are using the analog camera. Okay, but nowadays it's very difficult to find the analog camera. What we have learned in what we have obtained from the computer, everything is digital, because the computer itself is a digital world. Okay, when you save data, it's a digital signal, it's not analog signal anymore. So if you save the image inside the computer, of course it should be in digital image. Okay, it doesn't matter you using MRI, X-ray nowadays. If you remember, in X-ray structure, the last part is actually your intensifier. I think intensifier will connected with the CCD sensor. Actually, the CCD sensor will convert the analog signal from the intensifier into digital, because later when you want to save the X-ray, doesn't matter is it a chest X-ray or and so on, when you want to save it in computer, it should be in digital form. So that's why if you talk about image processing nowadays, is actually related to digital image. Okay, it's not related to analog image, so that's why that we talk that later in week number 1. And then second topic is about the medical image enhancement by using a spatial domain, and then we also have the image enhancement in frequency domain. So we will discuss that later. Actually is related to signal processing actually, because in signal processing you have a time domain, you have a frequency domain. So in image processing also, the time domain is replaced by spatial domain, the frequency domain still frequency domain. So that's why we have a spatial domain which is same, or the analogy is similar to time domain in signal processing. And then we also have a frequency domain where the frequency domain, the analogy is similar to the frequency domain in signal processing. Okay, and then we talk about the image restoration, and after that we talk about the medical image segmentation as well as morphological processing in image. Okay, and then regarding the assessment type, okay, there's a major changing there as compared to the last year or previous year. I have done some major changings there, where 10%, okay, 10% it will come from your quizzes. Okay, I plan to do either 2 quizzes or 3 quizzes, and then the mark later we will try to decide the mark later. Is it the highest one or the average one? Later we can decide, but I will provide maybe 2 set of quizzes or 3 type of quizzes, 3 set of quizzes. So we will choose either average mark or the maximum mark, okay, to be choose among these 3 quizzes to become your 10%. And then we also have assignments there. Okay, assignment might be a group assignment, and then there's a mini project implementation. Okay, this one, this one should be 25. Yeah, 25. Okay, so this one will come from Dr. Tan. Okay, because the second part of our class later will cover by Dr. Tan, and Dr. Tan will do the mini project and presentation. But sometime I'm see in the previous semester he always separate that mark into two part. Okay, sometimes they give you some small assignment and mini project where that total up to 25, and sometimes they also he also come up with some test or some quiz, a part of it, and then a few part of it is your mini project, meaning that the total of this thing should be 25 mark, and then we have a 50 mark for final exam. Okay, before I forget, the one that I will cover is from chapter 1 to chapter 4. Okay, that is, I will cover that before Dr. Tan, before it will take over by Dr. Tan, where Dr. Tan will cover chapter number 5 and number 6, which is medical image segmentation as well morphological processing. Okay, so that is the things related to this class. Okay, how about timetable? Okay, timetable later we can discuss in our WhatsApp group. Okay, after you all join the WhatsApp group, we can try to discuss about the timetable. Okay, I just share with you my timetable. Okay, that one, when someone requests to change the timetable, then I will share my timetable in WhatsApp group. So I will not share the timetable inside this video, because later it's very hard for you to define my timetable. So I will, for those might have for those who interested to change the timetable, then you might request in the WhatsApp group, then I will share my timetable, and you need to decide where to change it. Okay, if you don't have any objection with the existing timetable, then we can just continue with the existing timetable.